Good day and welcome to our first discussion this quarter. And as I discussed, I would like you to prepare your LAS page number 2, which is about the atomic theory of matter. So I will just discuss this particular lesson and try to give the important features of the atomic theory of matter. And as I discussed, I would like you to recall your grade 7 lessons in chemistry. Remember, we had this particular diagram, and I think you are very much familiar already with this concept that matter is just classified into two major groups. We have the pure substances and the mixtures. So as I discuss the atomic theory of matter, I would like us to connect our lesson now with your previous lessons in grade 7, specifically about classification of matter. So for the atomic theory of matter class, the main points really are just the following. First, matter is made up of atom or atoms, one kind of atom or different kinds of atoms. Secondly, and this there are just 118 different kinds of atoms, and these are just the 118 elements. And then thirdly, the atom has a structure, or a certain atom has a structure. All atoms, they have structure. And then atoms are composed of three major subatomic particles, and these are the proton, neutron, and electron. So overview for these main points, we have matter. Whatever matter we see is made of atoms, while atoms, a very small entity of matter, is still, it has parts, and these parts are the subatomic particles. We call them proton, neutron, and electron. So let me explain these points one by one. Okay, so let's start with the first point. Matter is made up of atoms. So as I discuss this particular concept or point in the theory, I would like us to have these three examples of matter. We have matter 1, aluminum foil. I think you're very much familiar with this. Second matter, we have white sugar. And then third matter, we have syrup. So let's start with the first example. Okay, so kindly evaluate the image. So you have their grayish circle or whatever, like balls of structures. So we have here the aluminum atoms. So aluminum foil class is just composed of one kind of atom, and this is the aluminum atom. So aluminum is an element, one kind of atom. Okay, so since aluminum foil is just composed of one element, so therefore, aluminum foil is classified as a pure substance because it's just composed of one element. Second matter, we have this one. Okay, earlier we had a quite simple matter, but this time it's a little complex. So this is the structure or the arrangement of the different atoms in the sugar, or also known as sucrose. So sugar is composed of, we have here 1, 2, 3 types of atoms. So sugar class is just composed of carbon, hydrogen, and oxygen atoms. And if we are to count the exact number of these atoms, they have a specific number of carbon. So carbon here are about 12. Hydrogen would be about 22, I guess, while oxygen is also fixed number. So all sucrose or white sugar, they would always have those numbers of carbon, hydrogen, and oxygen. That's why sucrose or white sugar is considered as a pure substance or classified as a pure substance because it's just a compound. So although it is composed of different atoms, many kinds of atoms, and of different numbers for carbon, hydrogen, oxygen, but the combination or the proportion of these atoms is fixed. So wherever you get the sugar, whether you have that from US, Europe, Japan, or from the Philippines, sucrose would always have fixed number of atoms of hydrogen, carbon, and oxygen. While syrup, okay, syrup class is just made up of water and sugar. Okay, so therefore, syrup is a solution. So recall that solution is composed of solvent. Here is water, while the sucrose or sugar is considered as a solute. So water is composed of hydrogen and oxygen. So you have here the structure, hydrogen and oxygen atom for water, plus sucrose, which is just composed of oxygen, hydrogen, and carbon to form syrup. But when you combine water and sugar to form syrup, the combination is not fixed, meaning it varies. So it depends on the person mixing the water and the sugar. That's why syrup is a solution. Therefore, syrup is classified as a mixture, not a pure substance, unlike the aluminum foil and the sugar. Okay, so those are the three examples of matter. Now we know that all matter is just composed of atoms, but depending on the kind of atom. There are matter that is just one type of element, while other matter could be different atoms, and when they are combined or composed of different atoms, the combination could be fixed, we have compound, or the combination could be varied, and we have mixtures for that. Next point, there are just 118 different types of atoms, and these are just the 118 elements. And these elements we see in the periodic table of elements, of course. So as of today, there are just 118 elements. We don't know exactly in the future if there could be more elements that will be discovered. But as of now, we only have 118 elements. Therefore, we only have 118 different types of atoms. And those are just the elements. So we have hydrogen atoms, carbon atoms, and so on. Next, this one. Atom has a structure. Okay, what do we mean by structure? If we Google search the word structure, we could see this one. Structure is just a noun, and it means the arrangement of the parts of a certain complex. So the complex we are talking here is just the atom. So with this definition, we could have this question. So what is now the structure of an atom? And what are its parts or components? And knowing the parts, how are these parts arranged, or what is the arrangement of these components? So let's try to answer that one with this illustration. So atoms class are just composed, as I said earlier, of three major subatomic particles. So when we say three major subatomic particles, therefore we could somehow say that atom could have other particles, subatomic particles, and the answer is yes. But these three major subatomic particles are the important ones, or they play a major role in the characteristic and the properties of each atom. So take note that in our illustration here, kindly evaluate. This is the helium atom, and you had this in page 2. So all atoms class, they have two regions. So the first region we have here is the inner region. We have the nucleus, just like the cell has nucleus. So atom has a nucleus. We call it the nuclear region. And in that region, we could see the two subatomic particles, and these are the protons and the neutrons. While in the outer region, we have there the electrons. Again, electrons are outside. In the nucleus, we have the neutron and proton. Okay? So it's not possible that electron is in the nucleus and neutron is outside the nucleus. It should be proton and neutron in the nucleus, while the electrons are outside, or in the outside region of the atom. Okay. So knowing these main points and somehow understanding these points, I have some questions for you. First, do all atoms have similar structures? Do they have one structure only? Second, Do the 118 different atoms similar? They have similar size, like one size only for all atoms in relation to its structure. And thirdly, like, are oxygen atoms smaller than hydrogen atoms? So these are the questions I would like you to answer as you answer the formative assessment after this discussion. So that's it for this first discussion about atomic theory of matter. See you on the next discussion.